Hi, my name is Kevin Wang, and this is Tiresias' box. This is a dynamic Braille translator for both English and Chinese that incorporates an idea for changeable Braille that's never been presented before. This is the first ever Braille actuator that uses physical cam mechanisms to change the positions of the Braille dots. So essentially, this takes a picture using this camera right here and extracts the text that it sees in real life and changes it from English and Chinese text in real life to text you could see on the computer. And then it takes the computer text and then translates it into Braille to output onto the Braille area on top of the box. This box is equipped with a Raspberry Pi 5 with 4GB RAM for high-level computer vision applications and electromechanical control. This also has an Adafruit PCA 9685 servo driver to safely power the servos used. It also includes a 12 megapixel autofocusing Raspberry Pi camera module 3 to be able to get the clear pictures for CV analysis from any distance. And as well as all that, we also have a button soldered to two GPIO pins on the Pi and simply two SG90 9-gram micro servos that are used to output the entirety of the Braille alphabet as well as the number system. So essentially, this project works by having these custom rotating cam Braille actuators, and this is the heart of the project, which are two custom-made independent rotating cams, each with a 3:2 gear ratio stacked on top of each other, which is to change the orientations of the pins, to be able to output every single letter in the Braille alphabet. The geometry was specifically mapped to be able to output all the letter combinations with the least amount of space. This also offers both Chinese simplified and English support, and this little box is able to both extract English text as well as Chinese simplified characters and translate it into English and then to Braille, covering two of the biggest languages in the world. The computer vision library I use is called EasyOCR, which is a library that runs optical character recognition, which is built on neural networks to help detect text in real life, and then convert it to the string characters which we see on our computers. I was able to code it directly with Python, and it utilizes PyTorch, which is one of the biggest machine learning frameworks for Python. Every time the code runs, the code creates a deep neural network model based on certain parameters to help you detect text and extract text in real life. I combined English and Chinese into a single model, as well as use a quantized model using 8-bit integers for optimizing how much numerical precision the model outputs, to reduce the latency and improve the processing speed and efficiency for the Pi. Since the Raspberry Pi is mainly used for CPU processing, the model also supports that, and using a quantized model, it also able to utilize smaller RAM and CPU processing, which initially uses GPU and VRAM. And furthermore, this model could also recognize numerous different font sizes and font styles, as well as Chinese characters and handwritten text. So how is this different from existing dynamic Braille actuators? So my unique approach uses a physical cam mechanism which changes the Braille rather than using existing models such as electromagnetic actuators or a motor for every single pin. Some of the main goals I hope to accomplish is using as few motors as possible and making the Braille dots move more smoothly but also stay rigidly in place when people's fingers are moving across them and pressing down on them. And many electromagnetic designs are not strong enough to hold up the force of people's fingers on the Braille, and the Braille pins in mine are in constant contact with the cam due to their light weight and force due to gravity, so they will have more than enough normal force to withstand the people's fingers. Furthermore, I also separated the cams into an inner and outer cam, which lessened the amount of motors to drive the Braille down to 2 servos to control the movement of all 6 pins. So now here's a demonstration of how this Braille actuator works. So you would first plug in the USB-C power source into the Raspberry Pi through the USB-C port opening, and the 5-volt power source into the PCA 9685 through the opening on the top right of the USB-C opening. Secondly, you would boot up the Raspberry Pi and wait a few seconds for the camera to start up and adjust to its surroundings, and then the Braille will move to its initial positions and then you're ready to use it. And then third, press the button to take a picture of whatever is in front of it, and the dynamic Braille will automatically change depending on the letters that it sees. It will go in order from left to right to the letters or words that it sees, first displaying the leftmost letter, and then changing to the next letter, and so on until all the text is displayed. Each character will stay for about 2 seconds until the next one is displayed. After all the text is displayed and the Braille is no longer changing, you'll be able to take another photo of different text and it'll show those different texts. And no need to worry about the memory of the photos, since after each translation, the photos that you have taken will be deleted to save storage. And you could press the button. You could also press the button for about 3 seconds, and the box will change. We'll be able to toggle and translate from Chinese to English or purely English for the photos that the user takes. The Braille that is displayed will be in English, and press and hold the button to switch the detection model again. And then press and hold the button for about 6 seconds, and the code will stop and the camera will power off. Make sure you do this every time to ensure the code stops properly and the camera powers off nicely. And this is a demonstration with Chinese characters, which this means art in Chinese. Here's a demonstration with handwritten text with menu. Thank you, Hack Club, for making this possible.